looking at a graph and determining the limit. The purple packet is your note packet for today and tomorrow. So today and tomorrow, Tuesday, Wednesday, will be in the purple packet. And then Thursday, we're going to get back to graphing. So you need to have graph paper if you don't already. Okay, so first of all, what is the definition of a limit? A limit is the y value. It's the y value of the function as it approaches x at a given value. And that's really, really, really mathy, okay? The one thing that I want you to write is that removables, because remember, there's 3 different types of discontinuities. What are the 3? Removable, infinite, and what else? A jump. A removable is the only discontinuity that has a limit. Because we're going to be looking at graphs. Gotta write it under it. I ran out of room. So if it's a jump or an infinite, the limit does not exist. And we usually just put D and E. D and E represents does not exist. So jump or infinite does not exist. So before we start looking at the graphs, let's look at these 4 equations. This is asking for the limit of this function as x approaches, let me zoom in really closely, as x approaches what number? -4. So to find the limit, we're going to substitute -4 in for x here and here. So let's go ahead and do that. Yeah, so far we always start off kind of, and it's not hard. No, I didn't think chapter 2 was hard. All right, so go ahead, use your calculator. So 2 times -4, -8. So we end up with 0 divided by -13. Can you divide 0 by a number? Why can't you? It'll be 0. But if you can still do it, right? You don't get an error. So the limit for this one is just going to equal 0. That would be my answer to A. So now for question B. For question B, the limit of this function as x approaches 2. We're going to substitute a 2 in. Let's go ahead and do that. 2 squared plus 3 over 2 squared minus 6 times 2 plus 8. So that would be 7 divided by 0. Can you divide 7 by 0? No. So when you get this, this is actually an error. So this is an example of D and E. So either a jump is happening there or infinite discontinuity is happening there. Something is happening at 2 in order for us to get a D and E. It's either a jump or it's an infinite. All right, let's look at C. Go ahead and try to do that one on your own. Substitute in -1, find the limit. Did you all get a fraction or a decimal? What'd you all get? 2/5. So your limit for this one is 2/5. So that means at that point where x is equal to -1, our y value is 2/5. Now we're actually going to talk about this one later. I'm going to save this for later because this is in behavior. Because see how it says approaches infinity? So we're going to talk about that a little bit later because that's a little different. All right, so now let's start looking at graphs. This is the big part. The majority of your quiz is looking at a graph and determining the limit. All right, so first of all, let's talk about notation. And I don't know if you want to write that down if it's not on your paper. But when you see this little minus sign after the number, the minus sign after the number, not before it. See at the very top? When you see a minus sign after the number, that means from the left. So from the left of the x value. This is just the notation that you need to get familiar with. When you see a positive sign after the number, that means from the right. And then when it says as x approaches a, that means at the point. All right, so at the point, which means in order for you to have a limit at that point, the left and right must be the same. If not, it does not exist. And again, a jump and an infinite does not exist. All right, so I'll give you a minute and then we're going to start looking at several graphs and determining the limit. No calculator needed. It's just looking at the graph. All right, so let's go ahead and look at this first one. So for part A, this is saying at 2, at the point 2. This is not saying limit. You don't see the LIM, right? This is not asking for a limit. Part A is asking what is y when x is 2. So this is 2. This is 1. So if I go up, you see how we have, first of all, what kind of discontinuity do we see here? A jump, right? That's important. Where is my closed circle? Is it here? Is it at the 1 or is it at 3? Where is the closed circle? 3. So that means that that's 3. Now, we have a jump. So if I draw a little wall here, I'm asking, what this is asking you is on the left side of that yellow wall, where does the graph touch the yellow wall on the left? So on the left would be over here. So what would be the limit? Where does it touch the yellow wall at? At 1. On the right side of my yellow wall, that's here. Where does it touch the wall? At 3. Now that means at 2 though. At 2, because the left and the right were different, the limit at 2 is DNE. We don't have a limit at 2 because what the graph is doing on the left is different than what it's doing on the right. And we have to reach an agreement to have a limit. D and E. If it's a jump or an infinite, it's D and E. At the point, though, the left and the right is not the same as at the point. All right, let's look at E. So now I'm moving over, and I'm going to move my wall right here. So on that pink wall, where is my closed circle? 2. So that would be the answer to E. On the left side of that pink wall, where does the graph touch the pink wall? On the left. So you would agree this is the left and this is the right. So where is it on the left side? Where does it touch the pink wall on the left? 3. So the limit from the left is 3. The limit from the right, though, is 2. And it didn't ask me for the limit at 3. But if it did, what would I say? D and E, because there's a jump at 3. All right, now let's look at 4. At x equals 4, we don't have a discontinuity. It's continuous. So that's pretty simple. We just have to list the point. So the limit is where it touches that blue wall, which is right here. And that would be 3. It's 3 and 3. Both of those are 3. All right, let's keep moving. So now let's look at a different graph. Now we got more stuff happening here. So let's look at this one. What this is asking you is the limit at 4 for number 1. It's asking you, what is the limit at 4? So let's see what's happening at 4. At 4, which would be right here, it looks like it's continuous. Would you agree? At 4 is continuous. So what would be my limit? What is that point? 2. So now let's look at 3. First, I need to find 3. It's definitely not continuous. So here's 3. On the left side of 3, notice what the graph is doing. It's going down. So we have an asymptote. So because it's going down, what is it approaching? Negative infinity, because it's going down. On the right side of that yellow dotted wall, what is it doing? It's constant. And where is it at? 2. Because these are different, they have to agree. If they don't agree, then the limit at that point is what? Does not exist. That's it. Okay, I'm going to give you a minute. I just want you to try to do 5, 6, and 7. Just try to do 5, 6, and 7. Do it in pencil or write it lightly, and then we'll talk about it. It's asking for the left side of 0, the right side of 0, and at 0. So on the left side of the pink wall, notice that I have an arrow going down. So that means it's approaching negative infinity. On the right side of the pink wall, I have an arrow going up. So that means it's approaching positive infinity. So what would be my limit at 0? Does not exist. Is the left and the right doing the same thing? One side, they have to do the same thing. Now, some professors say that if it's an infinite discontinuity, it doesn't have a limit. But some professors will say, well, if they both go up, then we'll say it's infinity. And if they both go down, then it's negative infinity. But if they're doing opposite, everybody agrees it does not exist. Okay, so D and E for 7. Now, what this is asking you for, this means positive infinity. That's the far right arrow. the far right arrow. The far right arrow in this example would be this arrow right there. And notice that it's constant. So what would be the limit as x approaches positive infinity? It's staying constant at what number? 4. So here, if you look at it, look like it's at x equals, y equals 4. All right.
It'll be the other arrow.
Yep, so I think that's the next one. So for number 9, it says negative infinity. This is the far left arrow. The far left arrow would be this one. So it's not constant on the far left. What is it doing? Pointing what direction? Up, right? So that means the limit would be what? Infinity. Positive infinity. All right. Let's look at -2. -2 has what kind of discontinuity? What do we call this discontinuity right there? A removable. Removable is the only discontinuity that has a limit. It's not D&E. So the reason why is because if I draw a pink wall, do you notice that the left side and the right side, they come together at the same place? So they're in agreement. So the limit is this point. Even though it's an open circle there, the limit is 3. Now I know it doesn't ask you that, but I want you to add something. If it asks you for this, go ahead and add this off to the side. If it asks you for f of -2, that would be D&E. And why do you think that is D&E? Because there isn't a closed point anywhere along that for us to evaluate. So f of -2 does not exist. But the limit as x approaches -2 is 3. Okay. All right, let's look at 11. +5. Well, first of all, we have what kind of discontinuity happening at +5?
A jump.
It's a jump. And all jumps have a limit of what? Does not exist, because the left side and the right side don't agree. The left side is at 2 and the right side is at 4. So the limit would be does not exist. All right, -5. -5 does not have a discontinuity. So your limit would just be where it hits that graph. And that looks like that's about -0.5, -1/2.
What's the difference between f of -2 and
So that's a good question. The difference of f of -2 is that when it says the limit, that means you're evaluating what's happening on the graph from the left and right. F of -2 is asking what is the y value when x is -2. Now, if I were to put a closed circle right somewhere around here, then f of -2 would not be D&E. But there isn't a closed circle anywhere along this for me to reference, so that's why it does not exist. All right, so let's go ahead and list our discontinuities. What kind of discontinuity do we have as x at x equals 0? Infinite. What kind of discontinuity do we have as x at x equals 2? I'm sorry, thank you. At x equals -2. That would be right here. What is that called? A removable. And at x equals +5, which is right here, what do we have? A jump. So the thing about limits is it's one of those things that you just have to do. You just got to jump in and try. So I'm gonna cut y'all loose. I want you to do example 4 all by yourself. And then we'll go through it together. See if you can answer all of those those questions, 7 questions.
I think I was on.
I was paying attention, I was answering questions too. I was laughing.
All right, go ahead and do those 7. We'll see how many you get right. Just take a guess, don't leave any blank. This is your chance to practice. If this was a quiz in 2 weeks, what would you write? And we'll go through it together, but I want you to try. You have all 7 answered. Put something for everything. Put your pencils down so I know who I'm waiting for. All right, let's grade it. One of these is a trick question too, kind of, because we haven't talked about it. All right, so when I notice that I have, you see how these are all talking about 3?
Yep.
First thing I do is I go look at what's happening at 3. What kind of discontinuity do I have at 3? Jump. So I automatically know that this is going to be D and E. C should be D and E. All right, so now when I look at the left and the right, so this is my yellow wall, the left side would be this point. That's the left. And at the left, it's hitting the wall at 1.
I can't count.
On the right side, it's hitting at 0. And then D is either going to be 1 or 0. And to do that, I'm going to look for the closed point, which is at 1. Now, the reason why I said that E is tricky, because we haven't talked about what happens when the graph stops. Keep in mind, the definition is that the left side of the line, so the left side and the right side have to do the same thing.
Would it be D and E?
It's D and E because there's nothing happening on the right. Now, if you missed that one, that's a trick question, so that's okay. Nothing is happening on the right, so there is no limit at 4. F of 4, though, is where you have the closed point, and that would be at positive 1. And then lastly, the limit as x approaches 1. So what's happening at 1? What kind of discontinuity do we have right here? A removable. That's the only one that does have a limit. So you should wrote 5. Okay, so that was how many? 2 for 7 questions. Who got at least 4 right? Okay, then I'm happy with that. All right, I want you to do the next one. We're gonna come back to that. All right, go to the next page. I just want you to do 1 through 10, and then we'll end there. Just 1 through 10. That's it. So 1 through 10. So we'll come back to that in behavior. We'll talk about that tomorrow. Today, I just want you to focus on determining limits, looking at the graphs, because the graphs are just going to have a whole lot of graphs. We're just going to keep looking at graphs, figuring out the limits. Because when you take your quiz, this is like 20 points. Just looking at a graph and telling me the limit. All right, go ahead and check your answers 1 through 10. Grade your work. See how many you got right out of 10. So I had 2, 2, 2, 1. That's the first thing I do is I look at the graph to see, is there a discontinuity? And if there is, what kind of discontinuity is there? So we do have a discontinuity at -5. It's removable. So the limit, for the limit, we're looking at this piece. For the limit. But for f of -5, I'm looking here. And then when we get to -2, that would be here. That's a jump. So I automatically realize that at -2, that's going to be D and E. Isn't it a jump where? Nope, at -5, that's a removable. That's a hole in the graph. So when you look here, let me zoom in. Do you see how From here to here, do you see how they're connected?
Yeah, I see they have the same closed dot.
But the graph, so the graph is the line. The line is connected. That's just a hole in the graph. This is a removable discontinuity. So we have a limit. But for -2, these two graphs are not connected. That's a jump. That's D and E. The left side is at -1. The right side hits at +4, which is why at that point is D and E. And for number 8, I'm looking at the closed dot, which is +2. And then for the last one, there isn't a discontinuity at 0. So I'm just looking at where it hits that yellow line, and that would be 6. Who got at least 8 right? Oof, not many. What about at least 6 right? Okay, 6 and more is passing. We in the 60%. All right, I want you to finish 11 through 20, 9, and then just put your notes away, and we'll go through those tomorrow. But before you leave, I want you to try to finish questions 11 through 29, and then we'll go over those